Good morning. This is Unit 1, Day 5, and we're going to talk about just graphical transformations. A rigid transformation keeps the original size and shape. This is also called an isometry. Non-rigid distorts the shape of the graph. So if it's a rigid transformation, then it says let C be a positive number, then if we have our original function plus c, then this means we're going to go up, and then whatever c is, so c units. If we have our original function minus c, it's just the same thing. We're going to go down, c units. Now, if we are going to substitute in x minus c into our function, then we're going to go the opposite. So minus means actually to the right c units. And then plus, we're going to do the opposite. So this is going to be to the left c units. Now we're talking about reflections. This is very important. When we reflect, when we have a negative in front of the function, then this is going to reflect everything across the x-axis. And when we substitute in a negative x, this is going to flip everything or reflect it across the y-axis. Let's talk about some non-rigid transformations. If we multiply something by our function, this is going to change the direction, change the shape of them. If we are multiply c by our function and c is greater than 1, then we're going to stretch it. If c is less than 1 but still positive, then we're going to shrink it. Okay, like a fraction, like a half, a third shrinks. So let's look at this. Our function has the absolute value of x. I'm going to do this one in purple. Okay, remember the absolute value of x, it starts at 0, 0, and it has this type of slope, right? Up 1 over 1. Now let's look at see what happens when we do our absolute value of x and then plus 2. So if you kind of look back at the first page, that we just said that it would move up 2, and that's kind of what this does. We're going to move up 2, same exact graph, nothing else changes. My slope doesn't change, nothing. Now, let's look at the original function, g of x equals x squared. This is a parabola. 1 squared, 2, 4, so 1, negative 2, positive 4, something like this. Symmetric. Now, minus 3 means we're just going to move it down 3. Let's do this one blue. So my vertex is right here, still up 1 over 1, but then we went up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So this is what this transformation looks like. Let's take a look at a horizontal transformation. I want you guys to try this one. I'm going to show you the number 4 first. So the square root of x looks kind of like this. 0, square root of 0, 0, square root of 1 is 1, square root of 4 is 2. So it kind of looks like this. And that is the original one. Now, when we move it, when the plus 3 is underneath the square root like this, we're actually going to change. We're going to do the opposite, right? So this is going to be minus 3, or to the left 3. 1, 2, 3. this is going to be the initial point. And then remember we went one up 1 over 1, and then we went up 1 over 1, 2, 3. And this is the transformation. Now, if they actually give you the graph and they ask you for the transformation, this is what we're going to do. We know that this is an absolute value function. It's a v. We need to know the parent functions. So I know this is something like g of x equals the absolute value of x, and then maybe plus or minus something, I'm not sure, and then maybe plus or minus something. Let me just change this. Okay. Now I need to look at the vertex. I don't know what happened. I need to look at the vertex. I moved it to the right one. To the right one. Remember that is affecting the x, so we're going to go to the right one, but we do the opposite, whatever's inside the parentheses or inside the absolute value symbol. So instead of going +1, we're actually going to do -1. Okay? And these are absolute value symbols. Let me just make them a little bit bigger so you guys can remember. Now, we're shifted it down 2. So down 2, we actually keep the same symbol, -2, on the outside of the absolute value sign. I want you guys to try 5b. Let's try a reflection. I really like the square root, so I'm going to try this one. The square root of x looks like this. Remember, 0, 0, 1, 1. Now, when we plug in 4 into here, the square root of 4 is 2. So 4, 2, this is what the original one looks like. It goes on infinitely. Now, we're going to reflect this, and we're going to shift it up 2. So reflecting it across the x-axis, you know, it's going to kind of look like this. I can kind of dash it for you guys. And then for -2. So it's going to go through this point. But then we have to shift it up 2, +2. So our final is going to look like this. So it was right here, up 2. And then there was a point right here. We're going to shift it up 2. So something like this, and it's going to pass the x-axis. There's no asymptote there or anything. Okay. Now the domain, in this case, my domain didn't change. We didn't shift it to the right or to the left. So my domain is the same as the domain of the square root of x, the parent function. It is 0 to infinity. Now we can include 0. That's actually a point. 0 is inclusive. Infinity never is. Now let's look at how this is different from the square root of -x. Remember, if we're plugging in a -x or substituting in a -x, we're going to actually reflect it across the y-axis. So let's write that down. Reflect across the y-axis. So we know what the original one looks like. A reflection across the y-axis is going to look something like this. And this is definitely going to change my domain. Okay? My domain goes all the way to the left. So this is going to be -infinity all the way to 0. I can't include 0. I never include infinity. I want you guys to try the next one. Try this. A non-rigid transformation. Let's try one of these. So in this one, f of x equals x squared looks like this. 2 squared is 4. -2 squared is still 4. Something like... But 1/2 x squared looks like this. So just a little bit compressed. but wider. Can you explain why this is a vertical compression? I want you guys to try number 8 also. And then we're going to look at what happens when we combine transformations. So I'm going to have you guys try 10. I'm going to show you number 9. It says that our original is y equals x squared. I just showed you what it looks like. It's a parabola. When we shift it 1 unit to the left, remember to the left and right, we actually do the opposite. And it's going to be y equals, it's inside the parentheses with an x. And we're going to do the opposite. So to the left usually means negative, but we're going to say plus 1. And then a vertical stretch by a factor of 2. Remember, the vertical stretch means we're going to have y equals 2 and then x plus 1. So this 2 is a vertical stretch. And then vertical translation. The translation down means we're going to have a minus 3. So this is going to be y equals 2, x plus 1 squared minus 3. That's it. All right, I want you guys to try number 10. That's all I'm going to do today, and have a wonderful day.